Exercise 327 is just giving you this molecule, and it's telling you as a fact it's one of the strongest known acids in the world. That hydrogen right there is one of the most acidic hydrogens known to humanity. And they're just asking why. So this is a nice summary of the different four factors. First, notice that it's on a pretty electronegative atom. It's on an atom that in a row is very far to the right. So when this hydrogen leaves, it doesn't take any electrons with it. It leaves as an H+, and the electrons in that bond, those end up becoming a lone pair on that oxygen. Now this is going to be a really good acid because that other H+ is able to get away because this negative charge is really stable. And it's stable because it has all four of these factors associated with it in one way or another. It's on an atom that's very electronegative, like we were saying. It's far to the right on the periodic table in a row. And what that means is that that oxygen is going to be able to pull this negative charge close to its nucleus, where there's positive charge, because of the power of its electronegativity. That helps to stabilize the negative charge. And notice that this lone pair is allylic into two places. Now not only that, but here's a pattern that might make your life easier, make it easier to see things in the future. If double bonds are ever conjugated, so remember that means single, double, single, double, single, double, single, double. Like if they're ever conjugated, if they ever alternate between single and double, then that allylic lone pair resonance pattern will start repeating over all of those conjugated bonds. So this negative charge actually spreads itself out over all of these bonds through resonance. And not just on that one side, but on the other side as well. So resonance helps, there's a huge amount of resonance that's helping to stabilize that negative charge. The more stable it is, the easier it is for the hydrogen to get away. Not only that, but we have a lot of induction going on. Look at these really electronegative elements. We have a lot of electronegative elements. Those are pulling the negative charge their way. As if resonance wasn't enough, these are pulling them over even more bonds, helping to spread that negative charge out even more. And the more spread out the charge is, the more stable it is, the more diluted it is. And so this is one of the strongest known acids because it has so many of those factors that we talked about stabilizing it. Now, it doesn't have the orbital. That would only be the case if, that would only make a difference even if you didn't have the other three factors. But because it has all three of these factors stabilizing the negative charge is really, really stable, and the hydrogen is able to get away very easily because because that negative charge is stable. It's not driven to stick back to it.